I would like to talk about the analysis of multiple steps for motion. Therefore, this is the subject for this part. Here's some graphs. Okay. Imagine there's a particle, and it has movement along a straight line or rectilinear motion, but it has many steps for its movement. For example, the first step, it has acceleration. In second step, it has constant velocity. For third step, it has decreasing velocity. And again, it has constant velocity as well. And finally, it has a final acceleration. Therefore, you can have multiple steps for your moving particle. And it can be discussed based on the graph. Let me show it to you. Imagine you have T and you have V. Okay, imagine here, have this graph at first. Next step, for example, you have horizontal line. Next one you have this graph. Finally, you have this. Therefore, you have some steps here. 1, 2, 3, 4 steps. And for each step, you can analyze it. For example, area number 1, what kind of motion is this particle? If you have a particle and it has 4 steps, what kind of motion is area number 1 or motion number 1? If you look at this graph and based on VT coordinate, you know vertical axis is velocity. And according to this line, you can figure out that you have a slope. And if you have a slope, it means you should have acceleration. And you have positive slope. It means you have a positive acceleration here. Definitely over here, you have accelerated motion. Number 1, accelerated motion. And because of positive slope, you have increasing velocity. Area number 2. What kind of motion is area number 2? Of course, it is constant velocity because it is horizontal and there is no slope. Therefore, area number 2, it is constant velocity. Let's switch to number 3. What kind of motion is area number 3? Of course, it is accelerated motion because you have a slope and that's positive slope. So you have increasing velocity. Area number 4. If you look at area number 4, you can figure out that you have negative slope or negative acceleration. It means you have decreasing velocity. And you can discuss it like that. Okay. Now look at the figure and look at the graphs. According to the graph, can you estimate which area has the highest acceleration? What do you think? By looking at this figure, you can answer this question. The maximum or the highest acceleration for this moving particle is step number 3. Why is it step number 3? Because step number 3 has maximum slope or highest slope. I mean this. It has highest slope with respect to others. Therefore, highest acceleration or area number 3 has highest acceleration. And you can analyze every step. Okay, now look at this graph here. Next example. Imagine this is V, vertical axis is velocity, horizontal axis is time. Okay, you have look at this one. There are 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Area number 1. What kind of motion is area number 1? Of course, it is accelerated motion because it has a slope, and that's positive slope. And one more thing. What is the sign of velocity for area number 1? You know here, if in order to answer this question, you have to look at the coordinate. You know here, if you have, this is 0 and 0, this is your origin. If you have velocity higher than origin or higher than 0, of course you have positive velocity. If you have velocity which is lower than origin, imagine it's here, your velocity is here. It is under the origin. Of course, you should have negative velocity. Therefore, depending upon the location of the velocity, you can judge about the sign. So if your velocity, your graph is upper than origin, of course, you should have positive velocity. Pay attention, sign of velocity is different from sign of acceleration. You have positive velocity and you have positive acceleration. Both of them are positive here. Okay, therefore area number 1. increasing velocity and velocity is positive. Area number 2. Look at area number 2. That's constant velocity because it is horizontal. There is no slope. What is the sign of velocity? Of course, it is positive because it is upper than origin. So constant velocity and you have positive velocity here. Number 3. If you look at number 3, you have a slope, and that's positive slope. You have increasing velocity, and that's positive. Here. Look at area number 4. What do you think regarding area number 4? In order to help you to answer this question, focus on the slope. Is it positive or negative? Of course, it is negative. Therefore, you have decreasing velocity. Number 4, decreasing velocity. But do you have positive velocity or negative velocity? Acceleration is negative, but velocity is different. If you look at area number 4, this line, it is upper. Do you agree it is upper than origin? It means you have a positive velocity, although acceleration is negative. Therefore, V is still positive. Number 5. So if you look at area number 5, you have negative acceleration. Acceleration is negative because a slope is negative. What about velocity? Do you agree this velocity here, it is under the origin? Therefore, you have negative velocity here. See? Negative velocity and negative acceleration. Now, focus on this point here. If you look at this point, according to the previous condition and current condition for this point, velocity here is positive before this point. After this point, velocity is negative because it is under the origin. So, and you know velocity is a vector. Therefore, here it means if your particle is going to the right and your origin is to the right, it means positive is to the right. Therefore, at first you have positive velocity because it's to the right. But finally, your particle will go to the left, which is here. And it means you have negative velocity because it's to the left. It is opposite to the positive sign. Of course, that's negative. Consequently, if you have positive velocity and you have negative velocity between these two, it means you should have zero velocity here, this point, this intersection point. Between positive velocity and negative velocity, you should have zero speed here. This intersection point called zero velocity. And it means your particle will stop here. And it will go backward. At first, it has forward motion to the right. That's correct. But eventually, it will go backward. What happens between the forward motion and backward motion? Of course, you need zero velocity between these two to change the direction. Consequently, this point called change in direction, very important. In other words, if you have this kind of intersection between your graph and your t-axis, and you have positive and negative velocities like that, of course, your particle will go backward eventually. It's so important. So you can write it down here. The particle will have backward motion. Because there is a zero velocity on the graph. I want to repeat it. If you have intersection like this on your graph, and you have velocity upper than origin and velocity lower than origin, it means you should have changing direction, and your particle will have backward motion. Thank you.